Alright, this video is going to cover parent functions and transformations. We're just going to talk about the parent functions we've covered this year. So let's start with the first one we did, which was the linear function. Y equals x is the equation there. Okay, the table that you're going to produce for this, so you've got an x and a y. Alright, and we'll just pick some x's that are common. You want to pick a couple negatives, a couple positives, and then just plug those into the equation over here and get all your y values. So for this one, the y's values are the same as the x values because x equals y. Alright, domain and range for this. Actually, let's sketch a little graph first, then we'll come back and do domain and range. So the graph for the linear is this diagonal line like this. Arrows on the end. So if we come back and do domain and range, okay, remember these arrows, we smash them down onto the x-axis, and then it's going to go left forever, right forever, and it's going to cover the entire x-axis. So our domain is negative infinity to positive infinity. Okay, the range, same thing. If we smash it down onto the y-axis, it's going to go from negative infinity up to positive infinity. Alright, second parent function, y equals x squared. Okay, similar looking table here. Okay, I'm going to pick the same x values. Alright, and if I plug those in, this time when you square a negative number, it becomes a positive. So negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So you notice how the y values kind of mirror each other right there. And that's what produces the graph that looks like this, called a parabola. So when we do domain and range for this one, okay, again, if you smash this down so it's flat on the x-axis, you're going to have an arrow going to the left forever and an arrow going to the right. It's going to cover the entire x-axis. That's negative infinity to positive infinity. The range, though, if you smash it down on the y-axis, it only goes from this point, the vertex, which is at 0, and it only goes up to positive infinity. So the negative part of the graph is cut out, and that's because when you square those negatives, you get a positive number. Alright, next one we talked about was y equals absolute value of x. Alright, make our little table here. Okay, I'm going to keep using these same x values until they're not going to be useful because it gives us a nice clear picture of what x is doing on both sides of 0. Okay, and when you plug it into absolute value makes numbers positive. So that would be positive 2, positive 1, 0, positive 1, positive 2. So again, you have that kind of mirror effect, but the numbers are a little bit smaller than they are with x squared. All right, and that's going to produce this type of graph, very similar to the parabola, except they're straight lines, and it makes a V. And the similarities to quadratics don't end there because the domain and range are going to be the same thing. Flatten those two out, and you get negative infinity to positive infinity, and push them together onto the y-axis, and you get 0 to positive infinity for the range. Alright, next one we talked about was the square root function. Y equals the square root of x. Alright, and this is where those x values are not going to be very handy because like square root of, first of all, a negative number would be imaginary, so I don't want any negatives. And then like square root of 2 isn't a nice square root. So I'm going to pick a couple different x values that are going to nicely work with this. So like 0 works, 1 is good. 4 is another perfect square, and maybe 9 can work as well. Alright, so square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Alright, so you only want positive numbers, and you only want numbers that are perfect squares, because that'll let you easily be able to make your table. Alright, let's take a look at a graph here. So this one starts like at 0, 0, and then it just goes up like this. All right, no negatives because, again, those will make an imaginary number. So it's only this little piece right here. So our domain and range are affected by this because now we don't have arrows going in both directions on anything. So I actually, if I scrunch it down onto the x-axis, I start at 0 and I go off to the right. So that's 0 to infinity. Same thing with the y. If I scrunch this down onto the y-axis, it goes from 0 up. So that's another 0 to infinity. All right, last one we need to talk about, or that we have talked about this year, is the rational 1 over x. So you got your x, y here. All right, going to go back to my normal x values, -2, 1, 0, 1, 2. All right, and now when you plug this in, you get 1 over -2, so that's -1/2. 1 over -1, that's -1. All right, this one you get 1 over 0. So actually should have probably left 0 out because you can't divide by 0. That's undefined. So we'll just scratch that one out, not use that. 1 over 1 is 1, and 1 over 2 is 1/2. Okay, this is that weird looking graph where you've got the two asymptotes on the x-axis and on the y-axis. And then you've got those two curves. One goes like this, and one goes like this. All right, so we go back to talk about the domain and range. I'm actually not going to use interval notation this time because it's a lot easier to write it a different way. So basically the only number that these don't touch is 0. All right, we talked about that in the table right there. Doesn't touch these two asymptotes. So for domain, we say x cannot equal 0. And for range, we say y cannot equal 0. All right, let's talk about transformation. So there's basically 4 different types, 4 letters and locations. So first one is an a in front of your function, a times the function. All right, this is going to cause you to have a vertical stretch or compression. All right, if a is greater than 1, it's going to be a stretch. So an example of this would be like y equals 2x squared. That would be a vertical stretch by a factor of 2. And then if a is in between 0 and 1, that's going to be a compression. So something like y equals 1/3 square root of x. That'd be a vertical compression by a factor of a third. All right. Also, you can get a negative a, and this is going to cause your reflection over the x-axis. So something like y equals -1 over x. All right. Type number 2 is a b value. So this one goes inside the parentheses, f of bx. All right, this is going to be your horizontal stretch or compression. All right, also I want to point out that this is opposite of what you think it would be. Okay, so just like the a, except it's opposite. So if b is greater than 1, that's going to be a compression, opposite. And if b is between 0 and 1, that's your stretch. And then if b is negative, that's going to be a reflection, but this time over the y-axis. So examples of these, b greater than 1, you'd have like y equals the absolute value of 2x. Okay, but it's opposite, so you would really take the reciprocal of that. So you'd say it's a compression by a factor of 1/2, 1 over 2. Okay, a stretch, you've got y equals, put this in parentheses, 1/4 x squared. Okay, with the 1/4 x in parentheses, again, you take the reciprocal of 1/4, and you would say that's a horizontal stretch by a factor of 4. Okay, and then a negative, you could have like square root of negative x with the negative on the inside of the square root. All right, and that's going to be a reflection over the y-axis. All right, third one is h, f of x minus h. All right, and this is your horizontal shift. Okay, so that's left or right. And again, this one, like the last one, is also opposite. So if you get a plus h inside the parentheses, that's actually going to move you left h number of units. And if you get a minus h, that's going to move you right. Okay, that's counterintuitive because the positives are on the right side of the graph and the negatives are on the left side. Okay, that's where the opposite comes in. Okay, so this would be like y equals x plus 4 squared, or something like y equals 1 over x minus 2 in those different parent function examples. All right, last one is k. So f of x and plus k is on the outside of the parentheses. This is your vertical shift. All right, so that's up or down, and it is not opposite. It is normal. So positive k, you're going to go up. Negative k, you're going to go down. So y equals x plus 4. Okay, it moves the parent function up 4 units. Y equals the absolute value of x minus 7. Moves that parent function down 7.